Okay. So here's where we're headed in this next chapter, which we're going to do about the next 3 weeks. Okay, between Thanksgiving and Christmas here. We'll work our way through this next chapter. You've probably heard, if you're in physics, you've probably at least heard of radians. And Mr. Foster's talked about probably going back and forth between radians versus degrees. Okay? Today is the day where you're going to learn what a radian is. And we're going to start converting back and forth between radians and degrees. That's what we're going to take a look at. Bigger picture, this chapter is what's called circular trigonometry, because we're going to be dealing with, there's going to be a lot of trigonometry, a lot of geometry, there's a lot of geometry stuff in this one. For example, some of the stuff you'll see. We're going to go back to Pythagorean theorem again. We'll use that. Okay? 30, 60, 90, 45, 45, 90. Maybe you remember those relationships. Maybe you don't. We'll revisit them when we need them. Okay? We'll bring those back. You may remember SOHCAHTOA, sine, cosine, tangent. Okay? We'll go back over. Matter of fact, that's where we're headed. We're going to start to come up with those sine, cosine waves, figure out where those are actually coming from, and actually work with those. And then in this chapter as well, we'll deal with a decent amount with fractions. There are going to be a lot of fractions in this chapter. Okay? We'll work on that as we go through that. Okay? So here's the idea as we work our way today. There are two ways to measure angles. Number one, you're very familiar with, in degrees. Okay? You've worked with angles from grade school on, and you've always worked in degrees. There is a second way, called radians, which is used a lot in calculus and beyond. Okay? There's also a third one, I believe, on your calculator. It's called gradients, but you don't have to worry about that one. You never have to worry about gradients. You're either going to be degrees or radians are the two. Okay? So just a heads up on that. All right. So, a little bit of background information today, okay, in terms of just terminology. When you go through and you graph, or when you're dealing with an angle, the initial side is kind of the starting side, and then as that angle starts to open, wherever it ends up is what's called your terminal side. Okay? Vertex is where the two rays come together, okay, the point. So initial side is your starting side. Like I said, terminal side is wherever you end up. And now we're not going to just look at angles that are between like 0 and 180. We'll start to look at angles that are bigger than 180. Then we can look at angles that are 800 degrees, that are 1,000 degrees, things like that, because of the fact that we're going in a circle. Okay? You got 360 in a circle. We could keep going around for a while. Okay? This angle, by the way, is about 55 degrees, which is approximately what 1 radian looks like. Okay? Just as a heads up. A radian is right around 55, 57, somewhere in there, 57 degrees. Okay? Now, a little bit more terminology as you take a look. Okay. So when we talk about an angle in standard position, you're basically taking an angle measure and you're going to put it on an XY axis. The vertex is at the origin. The initial side is the positive x-axis. And then the angle from there opens in that direction. Okay? That direction, which you're mostly familiar with, is the positive direction. Okay? So for example, that angle looks like it's approximately 120 degrees. Okay? Somewhere in that vicinity. You can also go the other direction. But if you do, you're going in a negative direction. Okay? Here's what I mean by that. Instead of opening this way, we could also go that way. Anybody tell me what that degree measure is? That's negative 240. Yep. That would be a negative 240 degree angle. The negative just meaning you're going the other way. Okay? You end up in the same spot, but you're just going the opposite direction. Okay? Greek letters that you'll end up seeing all used for angle measures. You're familiar, you should be familiar with theta. Okay, you did that. That was the Greek letter that was used in geometry. Alpha and beta are, again, other letters that they use to label angles. Okay, so you'll see all of those. All right. So as we take a look, and again, if I were to go through and actually add this concept, I said this is what's called circular trigonometry because we're going around in a circle. If I actually added a circle to this, a central angle, again, you talked about it in geometry back in the day, is the measure of an angle in degrees, or the measure of an arc in degrees. So for example, that 120 degree angle, you may or may not remember back to this, but matches up with, therefore, this is a 120 degree arc that goes with it. Okay? A central angle and its arc always match up. They always go together. So this is the arc I'm talking about right here. Okay? They have the same measure. 120 degree angle, this is 120 out of the 360 degrees in a circle. Right? Here's where a radian is coming from. Okay? Here's what a radian is. Here's how, at least in my mind, this is kind of how I separate between the two. If you think of that 120 degree angle as your angle in degrees, a lot of times when you think of radians, you're thinking of the actual arc length that goes with it. Not necessarily 120 degrees, but the actual length of that arc that goes with it. Okay? So for example, here's kind of the actual definition. So a radian is the measure of a central angle that intercepts an arc. And like I said, I highlighted that arc in red. They use the letter S for arc. Not quite sure why they use S for arc length, but they do. And a radian is whenever the length of the arc is equal to the radius of the circle. That is the definition of one radian. When the arc length and the radius are the same. So like I said, the connection or the difference between the two is if you think about the angle in terms of degrees, well, an angle always intercepts a corresponding arc. The arc is kind of how you can think about in terms of radians. Okay? So here's just a different way of wording what I have on that screen. A radian, one radian is when an arc length is equal to the length of the radius. Okay? That is what one radian is defined as. And so you might, again, if you're thinking about a circle, and obviously there's different size circles, you could have, a 1 centimeter radius versus a 10 centimeter radius. The idea is, you don't have to put this down, but I'll kind of explain. The idea is this. If that was, let's say, 1 centimeter, well, then you start working around, you say, all right, when I get to 1 centimeter with the arc, then I could draw the angle, and that angle is considered 1 radian. Well, then if we go to, let's say, 5 centimeters, that's kind of what this could represent. Well, let's say this radius is 5 centimeters. So I start working my way around the circle. When I get 5 centimeters around the circle, I can draw the angle in 1 radian. Okay? What's going to happen, if you remember back to geometry and similarity, when you take things and just enlarge them or shrink them, the angle does not change. That's one of the key parts of having similar triangles, if you remember back to that. Okay? The idea was the angles had to be the same, period. If the angles weren't the same, the triangles were not similar. It's the same idea here. The circle can be a lot bigger or smaller, but as long as the radius and the arc are the same, you've got 1 radian. That angle will always remain the same. Okay? So here's an idea. Let me try to get you to grasp the concept of radians here. It's not an easy concept, by the way. Let me preface everything I'm about to do today with this is not an easy concept. Okay? But the more you work at it, the easier it's going to get. All right, so first off, if you look at the picture, there's 1 radian right there. Like I said, if this is a 5 centimeter radius, well, then you start working your way around. Then you can draw the picture and say, all right, there you go. There's 1 radian. Matter of fact, I'll put that in, kind of circle that. There's 1 radian right there. Okay? Then, and actually even before that, I'm going to go a side note here. We'll go over to circumference here first. Let's take a look. Circumference, remember, is all the way around. Okay? It's the perimeter of a circle. It's the whole arc length, if you will. Well, in this case, you can very quickly find the circumference. Take your 5, plug it in. So you end up with circumference being 10 pi or 31.4 centimeters. Okay? I'll come back to that in a second, but I wanted to get that because we're going to revisit that idea. So here's the idea. Okay? Let's say there's 1 radian. Let's kind of work and figure out how many radians would get us approximately around the circle, around halfway around the circle, that idea. So if we go through and we add on another 5, let's kind of approximate that. Let's say there's another 5. There's what 2 radians would look like. Okay? You could draw that angle and it would be an obtuse angle. Okay? There's what 2 radians would look like. If we keep going, let's go another 5 centimeters, or at least approximately. There's what 3 radians would look like. Okay? We're almost halfway around the circle. Let's keep going. 4 radians. I could draw into this angle. Now we've got an angle that's bigger than 180 degrees once you're at 4 radians. Okay? You keep going. There's 5 radians. And if we go one more, it would be somewhere in that vicinity. There's 6 radians plus this little piece right here, plus a little bit left. Here's the connection I'm going to try to make now. Okay? When you go all the way around the circle, how many degrees? 360. Okay? This formula, when we went all the way around, what is 2 pi as a number? 6.28, right? 3.14 is pi. So 6.28 would be 2 pi. Didn't we just go 1, 2, 3, 4, 5, 6 plus a little bit around the circle? This formula quite literally says 2 pi radiuses, 2 pi radians. That's what this formula is. 2 pi is all the way around the circle. 6.28 radiuses will get you around every circle. Okay, regardless of whether it's a small circle, as you work your way around, that's what these numbers are in that I have circled. Okay, it's the number of radiuses that take you all the way around. And what ultimately happens, it's always 2 pi all the way around. Which means, by the way, how many, what would halfway around be? Pi. Notice here I said 3 got you almost to half. 3.14 would be halfway around. That's what this is. That's kind of the idea of what's going on. And like I said, I know it's an abstract concept, but that's kind of the idea at least. A radian, the name comes from radius. It's how many radiuses, if you will. That's not the right term, but it just works better. All right, in general, an angle measure in radians is just the arc length divided by the radius. Arc length divided by radius is what a radian is. And we said before, when they're equal, that's 1 radian. Okay? So that's where this formula is coming from. This is just the definition. Arc length divided by radius. And that, by the way, and I'll come back to this in a second, that's all I was doing right here. When I started circling those numbers and saying 1, 2, 3, if you notice, the arc length here was 10. Divided by the radius means that was 2 radians. That was that length. Right? That was, let me change colors so you can see it. That was that angle measure. 10 divided by 5 gives you 2 radians. If I added another one, 15 then, that arc divided by 5, 3 radians. That's all you're doing is arc length divided by radius. That's all that says. Okay? Now, sometimes it's not super nice. So let me give you an example of how we can use that. So if you were given this picture and said, find the measure of that angle. Right now, pretty difficult to find the measure of that angle in degrees. Unless you pull out a protractor or something and actually try to start actually measuring it, we don't really have much that we can do. But because of that formula we just said, we can at least measure the angle in terms of number of radians. All I have to do is take the arc length, which in this case is 31, and divide it by the length of the radius, which in this case is 12. And what do we get if you do that? It's 2 point something. 2.58. 2.58 is approximately what you end up with. What does that 2.58 mean? Yeah. This is 2.58 radiuses, if you will. If you took 12 and did the same thing, let's say there's 12, there would be 24, and then another, you'd end up, that's this angle, but measured according to its arc length. 2.58 radius is that angle measure. Okay? Again, I know it's an out there concept. I know it's not something you've dealt with before, but that's the idea behind it. All right, let's keep going. So now, one of the main things you're going to have to do in this chapter in general is be able to convert back and forth between radians and degrees. And so we just said before, if you go all the way around a circle, 360 degrees, which we had said, 6.28 radiuses got us there. That's 2 pi. Which then we said, if you divide both of those by 2, that means 180 degrees, halfway around a circle, is pi radians. Okay? There's your equivalent. So when you're going through and you're converting, we're going to use this as our conversion factor. The fact that 180 degrees and pi are really the same thing, radians to degrees. Okay? So, when you're going from degrees to radians, you're going to take whatever your degree measure is and just multiply it by that conversion factor, pi over 180. It's just like converting anything else. Feet to inches, to yards, to centimeters. That's all you're doing. You're just converting degrees to radians. So if you're in degrees and you want to go to radians, that's why the radians, the pi, is on the top, and the degrees is on the bottom, so that you can eliminate the degrees and go into radians. Okay? I think a lot of times when you think of like unit analysis, conversion factor, like I said, if you think back to like chemistry and to mole and all that kind of stuff, this is a much simpler version of that. You're just converting from one unit to the other is all you're doing, and that's the conversion factor. If you're going the other direction, if you have an angle in radians and you're converting it to degrees, well then you put the degrees on top because that's what you want to go into, and you put the radians on the bottom because that's what you want to cancel out. So you'd multiply by 180 over pi. In general, by the way, it's not always this case, but most of the time when you're dealing with radians, you're going to see a pi in the answer. Okay, you'll have something with pi in the answer when you're dealing with radians. Okay, let's do a couple of examples here. Let's convert back and forth between the two. So a 60-degree angle. Let's convert that into figure out what's the radian equivalent of that. Okay, let's start working back and forth here. I'm going to put it as 60 over 1. And again, if you think about that as 60 degrees, oops, that's not what I wanted. All we're doing is converting. So I want to go out of degrees and into radians, which means I multiply. You put pi on top because it's a radian. You put the 180 degrees on the bottom. And just like any type of unit analysis, if there's degrees on top and bottom, well then those basically cancel out. You're no longer in degrees. And now you can just multiply straight across. We get 60 pi over 180. And now just reduce the fraction. Okay? How many times does 60 go into 180? 3. So this is really 1/3 pi, but here's how you're going to see it. You'll see it written as pi over 3. Rather than 1/3 with the pi off to the side, they just put the pi in the numerator. Okay? That's how you will see it as you work your way through. So pi over 3 radians is the same thing as 60 degrees. Okay? And I know it's, like I said, right now it's probably not making a ton of sense because it's hard to grasp the concept of a radian when you've never dealt with it before. Let's do another one. 135 degrees. Let's convert that into radians. Again, same idea. Since I'm in degrees, we got to make sure the degrees are on the bottom then when I convert, so I get rid of that. So that's the 180 will be on the bottom. Its equivalent will be on the top, which is pi. And multiply and simplify again. What does that one simplify down to? 3 pi over 4. It's 135 over 180 is 3/4. So this ends up being 3 pi over 4. That's the radian equivalent of 135 degrees. Okay. Let's do one more, only because it's got a negative in it. Not that it's going to make any difference, but just because it's something a little bit different. Try that one. Do that one on your own. See what you come up with. What's the negative 270 degrees is what in radians? What does that reduce down to? What'd you get? Negative 3 pi over 2 is what you should get. Okay, negative 3/2 pi. Negative 3 pi over 2. which again, remember, the only thing that a negative does is it means you're just going the opposite direction around the circle, okay? So instead of going in the positive direction, you're going in the negative direction, 270 degrees, okay? All right, let's go the other direction. Let's do a couple where you're converting the other way. And actually, I think this one's easier when you're in radians and you're converting to degrees. And I'll tell you why here in a second. So number one, I'll show you the longer way, and then I'll give you a quicker version too. Neither one is all that bad. Pi over 6, if we're converting, we want to go 2 degrees, which means degrees need to be on top, so that's the 180. And the pi needs to be on the bottom to eliminate the radians. I say this one isn't too bad because what happens? The pi's cancel out, and what's 180 divided by 6? 30. That's a 30-degree angle. Okay. A 30-degree angle is pi over 6 radians. Okay. Now, I said there's another way of doing it as well. You can go through, and this is easy enough, but if you know that pi and 180 are the same thing, you could just take pi out and put 180 in. And then just take 180 divided by 6. Okay? If you know that pi and 180, it's a very simple substitution, and then get an answer. Try this one. Do this one on your own. 9 pi over 2. Convert 9 pi over 2 to degrees. What'd you get? Should be big. 810, yep. Should be 810 degrees. Easiest way to do it, take the pi out, put 180 in. 9 times 180 divided by 2 gives you 810. Okay. So it's 800. Now, let me see if again we can start to make a connection between the picture, if you will, and then the radians and the degrees. Excuse me. Agree, by the way, that 9 pi over 2 is really just 4.5 pi? Yes? Okay. Here's the idea. Let's say this was the axes that we talked about before. How far is it if I start here and I go to there? How far have I gone? 360, right? Okay. Or what in radians? 2 pi. So I've gone 2 pi. We got to go 4.5 pi. So we go another circle will get you to 4 pi, which now how far have I gone total? 720, 360 twice, right? And then you got another half a pi, and this is where something you'll start to get better at this as you work with it. Turns out, right there, half a pi is 90 more degrees. Well, if you take 360 plus another 360 plus another 90, you get 810 degrees. Okay? So, again, just trying to connect degrees to radians to the picture. And it's early, but you'll eventually start making that connection on your own.
What's that graph called?
What's it called?
Is there a name for like something like that?
Not really. No. It's a spiral. Yeah.
That's what we're talking about.
Yeah. No, nothing specific. Last one here for converting. Now, this one's a little bit different because notice there's no pi in this one. This is just 2 radians. And I want to convert those 2 radians into degrees, which means it's not as nice. I can't just take the pi out and put the 180 in. This one you actually have to use the conversion. Okay? So, since we're going 2 degrees, again, degrees are on top. Radians are on the bottom, the pi. If we multiply that out, we get 360 divided by pi. And if you actually do the division, what do you get for an angle measure? Should be a little less than 120. So like 114 something. 0.6? Okay, thank you. 114.6 degrees is approximately 2 radians. Okay. How we doing? I know it's, like I said, I know it's a very abstract concept of this radians being basically arc lengths. All right, let's keep going then. This one you may want to just take a picture of rather than write this whole thing down. Okay? I would just take a picture of that so that you have it. If you want to write it down later, then you can. All this is taking what you already know in degrees and just turning it into radians. And I'll explain here in a second. So if there's your initial side of your angle, anything in this first quadrant is between what degrees? If this was degrees. 0 and 90 degrees, right? This is just the radian equivalent. 90 degrees is pi over 2 radians. So anything between 0 and pi over 2 puts you in the first quadrant. If that angle opens up and let's say it's here now instead, now we've got an obtuse angle. This, we said, is 180 degrees. Anything between pi over 2 and pi, you end up with an obtuse angle. Okay, you're in the second quadrant. You could keep going. I could move this down into the third quadrant. Anything between 180 and 270. 3 pi over 2 is 270 degrees. Like I said, all this is just getting you an idea of, all right, if this is in radians, where am I? Trying to get you to visualize, where am I now thinking in radians versus degrees. Okay? And we'll practice this in a second. All right. So if you take a look at example number 1 here. This is where now we want to try to approximate this. And I'm going to make this easy for you at the beginning because eventually, would I like you to be able to look at this and say 5 pi over 6? All right, I think I know where that is. Yes. But for now, probably the easiest way is to do what with that? Convert it. Change it into degrees and then have an idea. What do you think? By the way, if you had to guess before you convert, which quadrant?
3.
1, 2, 3, or 4? 3? Keeping in mind again, the quadrant 1 starts up here. Quadrant 2, quadrant 3, quadrant 4. It's 2? Let's find out. If I convert that, if I take the pi out and we put the 180 in and we actually get the degree measure, that's a 150 degree angle, which means we are in quadrant 2. Okay? Yeah, pi is 180, so if you take the pi out, put 180 in its place and just get an answer. You're just converting it from radians to degrees. Now, let me again continue to have you work on trying to understand in radians. 180 degrees is what? Pi. Isn't 5 pi over 6 just a little less than pi? It's a little less than 1, which means it's a little less than 180 degrees. Okay? And that's, like I said, eventually, that's what I want you to get to. What do you think about problem number 2 here? First, second, third, fourth?
It's in 4.
All right. Let's see. So if I convert that to degrees, what's the degree measure? It's
Nope, 3.
you get 315 degrees, but don't forget we're going the other way, which means we are going 315 degrees, but remember the negative means I'm going in this direction. So it actually puts you back in quadrant number 1. Okay? 315 would have put you in quadrant 4, but because I went the opposite way, because of that negative, that's what that tells you to do. It puts you in quadrant 1. All right, last one. Let's see if you can do this one in your head. 3.93 radians. Where is 3.93 radians located? Somebody said 3. Who said 3? Why? 3.14 radians is pi, right? That's halfway. It's a little bit bigger than pi. It's 3.93. It's bigger than 3.14. Okay? So it actually puts you a little bit bigger. You could still calculate it. You'd have to convert it. This is 270 degrees, but you'd have to convert it, basically. Okay? But this one will put you in quadrant 3. All right, last thing I have for you today. One last thing. I know it's a lot, especially after having it off for 5 days. Yeah. No, we'll do that later in the week. No, we'll do that in Wednesday. All right. So you've actually done this already today. We just didn't name it when you did it. Remember that angle I said was like 120 degrees? You could go the opposite direction, negative 240, it's the same angle. Those are called coterminal angles. Okay? It's the same angle, but you can get there multiple ways. One of the other options is, because of this whole circle idea, when we were doing that 4.5 pi and we just kept going around in circles, that's another way that you can find another coterminal angle. You could say, here's 120 degrees, but let's take and go now all the way around the circle again. Let's add another 360 or 2 pi to that. You still end up in the same spot. Or let's go around the circle twice and add 720. Okay? Or 4 pi, and you still end up in the same spot. Okay? The idea is you can continually add 2 pi or 360 and end up in that. The terminal side will still be in the same end result. Okay? So, let me give you one last example here. Okay, so this angle, okay, the green angle that I have here, that angle right there is your 4 pi over 3 radians. Okay. I want to come up with 2 other angles that look just like this, okay, but come up with a different answer that are coterminal. Okay, so in this case, first one, we could do like we talked about. We could just go the opposite direction. How can I find that answer? Like how far I'd have to go in the opposite direction? What is it? It's not the reciprocal. You could take 2 pi, the whole thing, right? And then just subtract off what you already have. And that'll leave you with what's left to get you all the way around the circle, and we'll just go the opposite direction. So the idea is, if we're going to go 2 pi, here's where the fractions come into play again. When we're adding or subtracting, you got to have a common denominator. What is 2 pi in terms of thirds? 6 pi over 3, there you go. 6 thirds is 2. So if we take 6 pi over 3, that's 2 pi. All the way around, that's the total, and subtract off the 4 pi over 3 that we already have. That leaves you with 2 pi over 3, but remember we're going the opposite direction, so we need to make it negative. If you go in a negative 2 pi over 3, you'll end up in the exact same spot. One last one. Yeah, question? Hold that thought. Let me come back. Let me answer your question in just a second, because I'm not 100% sure what you're asking. Last one, like I said, what if we're going for a positive, rather than we know that's 4 pi over 3, but now let's say I wanted to keep going, and I ended up with that. Okay? You'll see, as eventually you'll see. Okay? Only difference is you've gone the 4 pi over 3, and now you add the 2 pi at the end, the extra loop around. So you'd start with your 4 pi over 3. To that then, we can just add 2 pi, but we need a common denominator. So again, 6 pi over 3. And therefore, 10 pi over 3 would just end up in the same spot. You'd go all the way around the circle plus the 4 pi over 3. Okay, so it's like a circle in a little more than a half a rotation. Okay? All right. What's that? All right, here is your assignment for today. Do the best you can. Like I said, I know it's day one. I know it's a totally new concept. Do the best you can on this, and we'll see. We'll go over questions right away at the beginning of class tomorrow. Otherwise, have a good day.